With that, I'd like to welcome Sam Weeks to the stage. Now you can come on up. Let's give him a warm welcome. Thank you.
Hello. Is this on? Yeah. Okay, hello everyone. Thanks for coming. Welcome to Gaining ML Insights with Google Vision API and MongoDB on Google Cloud. So a bit of a mouthful, probably needs a bit of a rebrand. But I am Sam Weeks. I'm what we call a customer engineer at Google Cloud. That means my job is to ensure success of UK organizations adopting Google Cloud, basically. So I'm not a MongoDB expert in any stretch. You've got a whole conference to ask MongoDB questions, just not in this 45 minutes. I'm joined by Matt Main, who's sitting there. Matt is part of our technology partnerships development team and is very close to the new exciting relationship between GCP and MongoDB, which I'll talk about a little bit in this presentation. But if you've got any more questions about the relationship specifically, then Matt's your man. He'll be around later. I'll also be around if you've got any questions. OK, so starting with this, and I'm kind of hoping that most people at least recognize the logo. Hands up. OK, cool. So it's Google Cloud, obviously. Hands up if you're using Google Cloud. Hands up if you're seriously considering moving to GCP. Hands up if you're not using any cloud provider at all. OK, a few AWS people in the house. OK, so I mean, everyone's using cloud here, so I can go through the boring sales slide quickly. I wanted to just sort of think about, before I give the talk, why do we care about cloud and what's good about it and that sort of thing. The first argument that always comes up is cost, total cost of ownership. Can I switch CapEx for OpEx? Can I streamline my operational teams or operational structures? And of course, can I pay for only what I'm using when I'm using it? So yeah, that's valid. I agree with that argument, but it's a bit boring, and I don't think we should see cloud as a kind of a cost-saving exercise. It should be something that delivers us new value, allows us to unlock like new revenue streams to do stuff that we couldn't do before because we couldn't reach the scale or have the sort of technical depth to do. Agility is probably my favorite. They're all my favorites. Agility, I think, is the most important, really, because we've got all this tech at our fingertips in like a self-service way, on-demand way. We can just experiment far more easily, spin something up. If it doesn't work, we haven't really lost anything. We can spin it down, and it just gives you the opportunity to adapt and change and be innovative, basically. So we can ideally be the disruptor in our industry, or if not, best case scenario, maybe be able to sufficiently react to the disruption that's going on. Lastly, connectivity, and important for this talk, is not just does a cloud give you access to the first-party tools that are on that cloud, it also kind of gives you a window into tech in general and the big dynamic ecosystem of tech, and gives us sort of integration points, but also sort of technical services and partners and that sort of thing that we can kind of reach out to. So on that, it's a good time to introduce, I suppose, Google's relationship with open source, first of all, which hopefully most see as a fairly strong one. Most of our tech, we open source ourselves. So Kubernetes is a great example, but that whole infra stack, Istio, Knative, Hadoop, and most of that ecosystem, TensorFlow, is kind of across the spectrum. Like you've got all these well-known open source technologies coming out of Google but being open sourced. And we want to make sure that we continue to contribute and participate in the open source ecosystem, I suppose. So that's when earlier this year, Thomas Kurian, our CEO, announced at our annual conference, Google Cloud Next, that we're doing this new open source initiative, which is basically a set of new partnerships with leading open source vendors to improve the customer experience or the user experience for a user who's using GCP alongside some open source tech like Mongo. Mongo itself is one of the more mature of the relationships. For Mongo, what it practically means is, first of all, you get a more sort of shared or streamlined support model, support process. Secondly, you get integrated billing. So if you were to stand up an Atlas cluster via the GCP marketplace, rather than paying out in two directions, your Atlas cost is kind of consolidated into your consumption costs for GCP. So it could simplify things for you. Lastly, hopefully, well, not hopefully, definitely, in Q4 at some point, we'll have UI integration. So integration of MongoDB into the GCP console, and directionally, this will mean that there will be little distinction between one of our sort of first-party services, like our managed cloud SQL service, for example, and Mongo. Mongo will become this sort of first-party document storage service on GCP. Any more questions on that? I'll probably start directing them to Matt. So what I'm going to do is have a bit of fun, basically, and kind of show off how easy it is to build a quick solution that bridges the gap between GCP and Atlas. So I'm going to create a image storage and classification solution. So I'm going to have a series of images of like famous landmarks, mostly like Big Ben, Eiffel Tower, etc. And I'm going to which currently have no metadata or classification around them, and I'm going to get them classified on the content in them using the Google Cloud Vision API, so our pre-trained visual ML service. And then I'm going to stick that metadata into the Atlas cluster, which I spin up from GCP. Okay. So I don't have to use the Vision API to do this. There are lots of different ways of kind of doing ML on GCP. Starting from your left, you've got kind of lower barrier to entry, faster time to value. Importantly, you've got low requirement for ML expertise, but the result will be a more general result. And then on the other side, you have the opposite, of course. More effort from your side, more expertise required, but the result will be more bespoke. So what this sort of looks like, if we were to categorize, like this diagram has, is on the left you have our models that we have created that have been trained with our data. So it's basically just APIs which expose a model which you can hit and get a response. The next one down is, for example, say I'm comfortable with data, but not necessarily a data scientist. So maybe I'm something like, I work in a lab, maybe I'm a scientist in general, maybe I'm a biologist or something like that. I have a specific use case, which a generally trained API isn't going to suit. And I have some understanding of data analytics, but not enough to go and actually play with the TensorFlow APIs. I may want an environment, a kind of no-code environment, where I can bring my own data and train on a particular use case in a kind of a safe, guarded way, so I don't, just go crazy and mess around with models that I don't know what I'm doing with. So, for example, say if I'm a biologist and I'm trying to find an anomaly with a cell, we could obviously do that with these models, but we haven't trained it against all cell anomalies. So you need to bring your own data and train yourself. And lastly is sort of saying, I am a data scientist. I know what I'm doing. I want full control of my data. I want full control of my machine learning framework, TensorFlow, Keras, whatever you're using. All I want from you, Google, is to give me a kind of managed or serverless environment where I can just come in and use a Jupyter Notebook or something and design how I want things to run, but then Google then is in charge of spinning up the the hardware that I require and connecting all of the hardware via our distributed private fiber network. And obviously, I don't want to have to pay for all that kit. I just want to rent it. Make sense? So why have we done this? Well, fairly obviously, and there are lots of sources that show this. This is one of them. Basically, the amount of machine learning skill does not equal the amount of machine learning demand. So this particular slide says 21 million developers, fewer than 1 million data scientists, and in the thousands only of deep learning researchers. So clearly there's a massive skill gap, and large tech providers and people considered subject matter experts in the field of ML probably need to create some kind of way of dealing with the skill gap by creating more self-service, more accessible solutions for machine learning, which is what we have done. Okay, so now I'm going to start the demo. I have tested the Wi-Fi. It's not as fast as it was at home, so it did work, but it took a bit longer just to stress me out a bit. So what we're going to see is, as I said, I'm going to first of all build a new Mongo Atlas cluster on GCP, and I'm going to do that via the marketplace. So the marketplace is a kind of a window front to GCP with like prepackaged solutions that you can pull down from and easily install and deploy. I would have liked to start from scratch and provision a VM and put a web server on it and put the source code on to run an application, but it was going to take a little bit too long. So instead, that bit's already running. I'm just going to update the code to include the connection string for MongoDB, so I can actually make a call to Mongo. A couple of things we need in GCP, which is so the web server listens on port 8080, so I need to create an ingress rule so I can actually access that. And then I need somewhere to actually put the images. So I'm going to put the images in object storage on GCP. So Google Cloud Storage is our object storage service, which makes sense because images, large, immutable data, doesn't need to do anything, just sort of sit there. But then the metadata for that I'm going to stick into MongoDB, where I can index against it and therefore search against it and actually identify which of the images contain whatever it is that I'm searching for. Yeah. So then we'll start the server, bring up the UI. The UI is embarrassingly simple, so apologies for that in advance. And there's a little button which will start the process of sending an online batch prediction to the API. We'll get the sort of classifications back as JSONs, and we save those as objects into MongoDB. And then we'll go and have a look in MongoDB, and we can actually have a look at how well the Vision API has performed. Hopefully it's performed completely well. Of course, I've tested this, so I know which ones are going to work and which ones aren't, but I haven't just taken out all the few anomalies where it didn't work. I haven't taken them all out, so there is one case which it can pick up on, which I thought might be interesting to see. Okay, so let me. Okay, so this is GCP, the GCP console for those who haven't seen it before. The first thing to start with, I've created a project called MongoDB Vision Demo, which is clean completely except for that VM that I mentioned that's running, which is just here, and that's basically all that I've got in here. So as I said, the first thing I'm going to do is go to the marketplace and create a new MongoDB Atlas cluster. So I'll search MongoDB. That's gone wrong already. Hang on. That's better. So you've got the free tier or the proper enterprise version. The proper enterprise version is the one that's associated with the partnership and will link my billing and all that sort of stuff. I'm just going to use the free tier, so I don't have to apologize to my boss, basically, about. So yeah, so I'll need to sign up. So I'll launch a new cluster. So new email address. Is it too small? Make it a bit bigger. Okay, so build my first cluster. GCP, of course. I'll use where the free tier is available, so our Belgian region. Because I'm using the M0 free tier, there's not much configuration I can do, so I'll skip all that and just create the cluster. So we've got a cluster coming up. Whilst that comes up, I will give it a user. And of course, again, having a sort of named user is not best practice, so you wouldn't do that if you're going to call it from an application, of course. But just for make things simple, I will. And network access, and again, I'm going to just do from anywhere, but you would, of course, go and make sure you only allow the IP where my server is. So whilst the cluster spins up, I can go back into GCP, and then we can create the GCS bucket, put the images into there, create the firewall rule, then go and get the connection string from the cluster, put that into the code, and then run the server, right? So I've got to go storage, create a new bucket, and it is vision demo images is going to be the name. I can decide sort of across how much of a geographical area do I want to spread my bucket and spread my data. I'm going to go with regional. So GCP is zones, then regions. So I'm going to put it into the Belgium region and spread it across the zones in the Belgium region because that's where I put my MongoDB cluster. So it makes sense. I choose my storage class. So as I go down this list, I basically get cheaper storage, more expensive retrieval of that data. So say it's like archived logs or something, you can stick them down here. I'm going to put mine up here because I need to retrieve them. I'm going to set my access control at the bucket granularity rather than being on the objects because I don't need to go that far down. And I'm going to let Google manage my encryption key for me and rotate it and store it securely, and so I don't have to worry. Okay, so now we've got a bucket just coming up. Now we need to stick the images in, which are here. So on my local machine, I've got a few pretty famous images. That one is the one to look out for, whether or not it'll be able to recognize Christ the Redeemer. Obviously, that's pretty small, so we'll see if it can manage to do that. Angkor Wat, Cambodia, Arc de Triomphe. I'm going to use command line to put these up. Okay, that looks good. Okay, cool. So we've got images in our bucket. Last thing is a firewall rule. New firewall rule. TCP ingress on port 80. Allow. So what's quite cool about networking in GCP is it's all abstracted onto a software-defined layer. So you're kind of like removed away from worrying too much about CIDR blocks and things like that, and you can specify firewall rules to apply to resources based on tags. So I can just tag my resources, tags and VMs, and say, oh, this firewall rule is going to apply to those tags. On this network, I only have one VM, so I'm not going to bother, and I'm going to say the source IP can be from anywhere. That's the important bit. And create. Okay, so now we're basically completely ready, except for making it talk to Mongo. So my cluster is alive. I can connect. I can get a connection string, copy that, and now I need to put that into the Node.js application that's on the server. This is the code that's on the Node.js application. Can you see that just about? So super simple UI with basically not much on it. A little bit of client-side JavaScript, which is basically listening for a button to get clicked. If it does, Server side will do a number of things, including use the Vision API to detect landmarks, detect safe search. So this is things like gore, explicit images, and swearing, and like text, explicit text. You can see them here: racy, violent, spoof, medical, and adult. And then label is your sort of like generic labeling of the sort of day-to-day objects that are in this image. So like, we'll see things like sunset, sky, bridge, flower, that kind of thing. So I need to make sure I've got my Vision demo images, so the name of my bucket and the connection string is that. I hope I copied the password right, or I remembered it right even. So that's what we need to put in. So I'm going to now go back to the VM, SSH into it, and remove that server.js file and create a new one with what's copied into my clipboard, and then we can start it. So it's that server.js file I need to take out. Create a new one with what's in my clipboard. Save, close, and now launch server. Server-side code running, successfully connected to MongoDB Atlas, that's good. Listening to port 8080, the input bucket is set to Vision demo images, so that sounds okay. So now let's go and have a look at our glorious, glorious front end. There it is. Not much. So we've got a button here which is going to do the work for us. Once I click that, it's going to go to the bucket and do an online batch prediction. So get all the images in one go, send them synchronously to the API, get a classification on all of them back, and then bosh those into, well, first of all, create 3 collections in Mongo: landmarks, labels, and safe search, and then put the objects into each of those collections. And this was erroring this morning, just to let you know, so we'll see what happens. Okay, that looks good, no error, and number of total files processed is now 10, which is good because I've got 10 images in my GCS bucket. So that's worked, basically. Excellent. Now we can go and have a look into actually have a look at what it's created, and now we can see how good the Vision API is, or bad. You guys can be the judge. So it looks like it's worked. Database, 3 collections, safe search, landmark, and labels, 1 of 10 in each. So what I've done is obviously added the actual unique URL to get the image. So obviously, like phase 2 of this demo, you'd obviously be able to search on the objects, and then I guess the application layer would be able to take the URL and go and grab it and return it onto the UI. So we need to make sure that it's linked to the metadata, of course. So this is all the labels that it's detected with this percentage likelihood. So this one's pretty good. Sky, mountainous landforms, nature, mountain, atmospheric phenomenon, sunrise, morning, natural landscape, hill, sunset. If we have a look at it, that's Christ the Redeemer. So that's the one which isn't going to be able to get labeled, isn't going to be able to get a landmark attached to it. But this one, sky, landmark, temple, historic site, cloud, architecture, tree, Hindu temple, place of worship, morning. Is it Angkor Wat? It is Angkor Wat. Triumphal arch, what'd you guess? Classical architecture, landmark, monument, facade, ancient Roman architecture, Arc de Triomphe. Cool, so it's basically done a pretty good job. I don't know what you guys think, but I think that's not bad. Let's have a look at the landmarks and see if it's managed to get any of these right. So Arc de Triomphe, 78%, happy with that. Angkor Wat, 50%. Taj Mahal, 90. Let's have a look at that one. It's a pretty obvious one, that one. It's like the Taj Mahal picture. Machu Picchu Mountain comes up very high, 95. Machu Picchu a bit lower. Yeah. Giza Necropolis and Great Pyramid of Giza at 79 and 74. I think you get the idea. But importantly, Christ the Redeemer, to call it out, has not been managed to be tagged. So round of applause for Vision API. Way! Cool. So yeah, I haven't done anything special. I've just used the Vision API as is, sent them, and that's how they come back. So back to the presentation, a few slides. We're probably going to finish early, which I'm sure is a good thing. One thing I wanted to call out was that these APIs, pre-trained APIs, I intentionally used the phrasing a general output and a non-general output when I introduced the spectrum of ML controls in GCP. That's because often these are sort of thought to be like proof of concept, pilot kind of thing, and then you want to progress to something like further down the line. That's not true, actually. And here's an example of an enterprise customer using the Vision API in production at scale, basically doing what we've just shown, i.e. Creating a system where they can add metadata or add classifications against their images or their customers' images so their customers can search on the content in their images. So I just thought it was quite an interesting kind of reference to bring up to point out that all they're using is that Vision API here. They're not doing anything clever. This demo has been published, so if you want to do it yourself, you can. I've changed it a little bit, but it's 80% is kind of the same. So have a look and do it yourself. Next things I would suggest would be, no worries. Next thing is, Matt and I will be around today, so obviously that was fairly broad and general. I don't know how much other cloud content there's been. I don't think there's any other GCP. I think there's one other AWS one. But if you want to, in general, talk to me about anything about GCP, please do, and we can get a few more hands up. And anything specifically about the MongoDB GCP relationship, Matt will be around, and or sort of PJ as well from the Mongo side may be around as well. We have a booth. I should have known that. Come down to our booth. Where's our booth? Upstairs. And next, step 2, no excuses about not being able to do your homework, because you can sign up to GCP for free, and you can get $300 of credits to use. And you saw me spin up a free MongoDB cluster as well, although I'm sure you guys have probably got access to MongoDB. So no excuses for not doing it, basically. Here's my feedback form if you want to give me some feedback, and thank you very much.
Thanks, Sam. Does anybody have any questions for him that I can bring the microphone over?
Thanks. That was a great session. Just one question. This capability is pretty powerful. Any examples from banking or telecom or utility industry kind of usages?
Banking, I'm not that close to, so I can't comment. I think OCR in banking is very common as a general rule. I can't think off the top of my head of a GCP shareable use case necessarily, but I know that like OCR is very, very big in FS. Telco, telco and media, I've got a few that I can talk about, which is using more to do with like video. So I showed you the image API, but we've got a similar one for video. So doing things like automatically finding scene changes, automatically tagging for nudity is very helpful, and expletive material also makes a very good demo. Yeah, I'm afraid I can't give you any. I am aware of UK customers doing that. I can't give you the names for those, though.
Any other questions? One more? Okay.
Sam, where else do you see GCP use cases being, not specifically this one, but what industries you see that the adoption is going through the roof?
Yeah, I mean, GCP is used across all industries. We find it being adopted more by, let's say, more technical audiences, more technical organizations. I think a good example of that, and one that I work in a lot, and also I know one that suits Mongo quite well, is gaming. I know gaming is very, 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 very popular, and we're seeing a lot of that in the UK at the moment.
Thank you.
Anybody else? Okay. So again, the booth is upstairs, near where you had grabbed food earlier. So with that, let's give him one more round of applause. Thank you, Sam.
Thank you.